Hello friends, welcome once again to ASOMNOF Online Maths. In this video, I'm going to profile a solution to this simultaneous equation using the Gaussian elimination method. To do that, you have to transform this into a matrix first. You transform it into a matrix. You have coefficient of x here is 1, coefficient here is 2, and you have 3. Coming to this row, you have 1, 4, and 6. Coming down here, you have 2, minus 3 and minus 5 equal to 9, 1, 0, 9, 1, and 0. Now, the idea of Gaussian is to make sure that the leading diagonals are all 1, while the other elements here are 0. If you're able to achieve it, it means you've understood the Gaussian elimination method. And to do that, here is already 1. We are good to go. Then make sure that this is 0 and this is 0. This is 0. Here is 1. Here is 1. So let me make this to be 0 by multiplying this by 2. If I multiply 1 by 2, I will get 2. And 2 minus 2 is 0. So I will say 2 row 1 minus row 2 will give me the new row 2. So 2 times 1 is 2, 2 times 1 is 2, 2 times 2 is 4. Then I will now say 2 minus 2 is 0, 2 minus 4 is minus 2, 4 minus 3 will give me 7. And you multiply this also, this row by 2, here is 18 because you're multiplying everything 18. Then minus row 2. 18 minus 1 will give us 17 because you multiply everything here by 2. Then overshift this. Let us make here to be 0 as well because everything here and here must be 0. To make it to be 0, I have to do 3 row 1, then minus row 3 because 3 times 1 is 3 and 3 minus 3 is 0. So I have to say 3 row 1 minus row 3 will give me the new row 3. 3 times 1 is 3, 3 times 1 is 3, 3 times 2 is 6, 3 times 9 is 27. So you say 3 minus 3 is 0, 3 minus 6 is minus 3, 6 minus 5 is 11, and 27 minus 0 is still 27. Then to continue, you need to make here to be 1. And to make it to be 1, just divide it by 2. By minus 2 to be 1. So I can say row 2 over negative 2 will give us our new row 2. So minus 2 by 2 by minus 2 is 1. 7 by minus 2 will be minus 7 all over 2. 17 by minus 2 will be minus 17 all over 2 as well. Then we need here to be 0. To make this to be 0, I can say 3 row 2 plus row 3 makes this to go. Because 3 times 1 is 3, 3 minus 3 is 0. So 3 row 2 plus row 3 will give us our new row 3. So 3 times 0 is 0, 3 times 1 is 3, 3 times minus 7 is minus 21 over 2, and 3 times minus 17 will give us minus 51 over 2. Then minus plus row 3 to get this. So 0 plus 0 is still 0. 3 minus 3, here will be 0. And minus 21 over 2 plus 11. To make it to be better for us, this 11 can be seen as 22 all over 2. Because 22 by 2 is 11. The reason of doing that is to make sure that this is 2, this is 2. They have common denominator so that you simply add their numerator. So this is something I'm saying minus 21 over 2 plus 22 all over 2. If I do that, I'll have minus 21 plus 22, which is 1 all over 2. So this is just 1 over 2. 1 over 2. Okay. Then minus 51 over 2 plus 27. This 27 can be seen as 54 all over 2 because 54 divided by 2 is 27. So minus 51 plus 51 plus 54 will give us 3 over 2. So this is something as 3 all over 2. That is what it will be. Okay. Then the next thing we've achieved here to be 0, here is 0, here is 0. What is left is here being 1, because here must be 1 for us to get what we want. So to make that place to be 1, we have to multiply it by 2, because half times 2 will give us 1. So we multiply row 3, 2 row 3 will give us our new row 3. 2 times 0 is 0, 2 times 0 is 0, 2 times half is 1, and 2 times 3 over 2, 3 over 2 times 2, it will give you just 3. So here is now 3. So we achieved it because everything here is now 1, which means this is the same thing as saying x plus y plus z equal to 3. Therefore, z is 3. Because 0x, 0y, 1z, which is z. So z is 3. So you write z is equal to 3. Then coming here is x 0 plus y plus minus 7 over 2z equal to this. That is, this is gone. So I'll call it y minus 7 over 2z equal to minus 17 over 2. Already z is 3. Put 3 here. Minus 7 times 3 is minus 21. So you have y minus 21 over 2 equal to minus 17 over 2. This minus will come here. It becomes a plus. So y is the same thing as minus 17 over 2 plus 21 over 2. Now they have the same sign. Minus 17 plus 21 will give us around 4. And 4 divided by 2 will give us 2. So our y is 2. Now let's go for x. Coming here, x plus y plus 2z is 9. X plus y plus 2z is equal to 9. Already we've known our y is 2. So I'll write x plus 2 plus 2z. That is 2 times z, which is 3. 2 times 3 is 6, equal to 9. So x will be 9 minus 2 minus 6, because all this plus crossing over becomes minus. And that will give us 1. So therefore, x is 1, y is 2, and z is 3. This is the solution to this particular simultaneous equation using the Gaussian elimination method. If it is Gauss-Jordan will not only make here and here and here to be 0, we also make everything to be 0, so that the value of x, y, and z will be clearly written. That's just the difference. So just look for what you do to this, and this to make them 0. That is what Gauss-Jordan is talking about. But Gaussian elimination method is just interested in making here and here to be 0, so that you can easily get x and y and z by substitution. Thank you for viewing, and may God bless you.